too late and my laptop's no longer on the screen. Testing. Test, test, test. Testing the microphone. Another test. Testing, testing. Microphone. Oh, we're testing. Yes, yes. Microphone. Microphone. Testing the microphone. Don't worry, I'm not. We just need to test the audio. Yeah, word. Yeah, not starting just yet. Yeah. Okay. Wait a second. All right, everybody. Hear ye, hear ye. I said hear ye. Okay, welcome everybody. Thank you so much for coming to our Godot workshop. I'm Max. I'm the president of our uOttawa Game Development Club. We are hosting this event in grateful collaboration with Hack the Hill and CSSA. Woo! Let's get a round of applause. Woo! All right, so yeah, thank you guys all so much for coming. In this workshop, I am going to be making a little game in Godot and explaining all the steps out as I go along. And if you guys want to follow along with Godot open, that is very much encouraged. How many of you guys intend to follow along? Can we get a show of hands? All right. You guys got Godot installed already? I see a few hands. Wait. Let's do that one more time. Out of the people who want to follow along, are there any of you who don't have Godot already installed? Any of you who still need to install it? No? All right, I'm not seeing any hands. Great. I suppose that means we can get started. Well, actually, you know what? It seems we might have a few more stragglers coming in. You know what? Why don't we? I'll just talk a little bit beforehand about why we chose to give a workshop in Godot today. So, me personally, I historically have used Unity. I've used Unity for about 7 years, and I dabbled with some other frameworks in the past. I used Pygame and there's some old Java libraries, but I stuck to Unity mostly. And as some of you may have heard, Unity's been in a bit of a pickle lately because they, about 2 weeks ago now, they put out some really, really awful and controversial changes to their pricing model that were just really scummy and really poorly thought out. And they have since, after a huge, gigantic, major shitstorm from the Unity user community, they have, made the standard corporate apology and made some actually pretty good changes to their model, but they lost a lot of trust with that move, and it's going to be a while before they get that back, if ever. And a lot of people who formerly stuck with Unity, such as myself, are strongly considering now moving to Godot because Godot is open source and free and not piloted by some giant, opaque corporation that could, tear it away from you at any moment if they so chose. So, also Godot's just a really good beginner engine in general. I don't know if, are any of you guys first years? Yeah? I suppose you guys must be taking ITI 1120. They still teach Python in that? Okay, that's good, because Godot, actually, their built-in scripting language, GD script, is actually entirely Python-based. So you'll be able to transfer all of your Python knowledge. It's pretty cool. All right, now with the Godot spiel out of the way, oh yeah, I guess I should mention we've got snacks and pizza incoming in a while. So the plan is to spend maybe an hour or so workshopping, then take a break for snacks and pizza, then another hour finishing up the workshop. Sound good? Yeah. All right. Okay, so to start with, I've actually got open here the project file for the game that we're going to be making. So just to show you guys what the end product's going to look like, I can just hit this little play button in the corner to run the game. All right, brace yourselves, it's pretty awesome. Okay, my laptop might be a bit, okay, yeah, got a second. I don't know if any of you guys have ever played Doodle Jump, if any of you are ancient enough to remember that old iPhone classic. But it's kind of, it's taking a little while to load. My laptop's under a bit of stress right now. Okay, well, I wasn't prepared for it to take this long to open. It's to be quite honest. Well, anyways, I'll describe it until it decides to come up. I'll describe it. Oh, there we go. It's very small. This also is not expected, and okay. Well, you can kind of make out what's going on. Basically, your little guys here, you have platforms that are randomly generated around the screen. We're going to hit the space bar and jump into the air, and the idea is just to keep bouncing on the platforms through the air as long as you can. And we got some other stuff here going. We got, oh my god, I don't know, something just fell off the top of the screen. Better not touch that. Don't want to hit that. So yeah, some of the topics we're going to be covering here are, setting up sprites, setting up controls, setting up the spawning of objects, game logic, starting the game, ending the game, calculating score there, as you can see in the top, and adding text to display that score. And let's see if I can't. I've died. So that's a little demonstration. We will now create our new project. So have you guys all got Godot open? Yeah, we got Godot open. All right. I am going to open the screen that comes up when you open Godot, the new project list. All right, so we're all at the screen. Yes, looks familiar. I will take that as a yes. So we can create a project by, if you look over here on the right of our lovely screen here, we can hit New Project, and we can enter our name here. I'm just going to call it Mac Jump Game. Oh yeah, I forgot to introduce Mac, that little monkey guy in the game who is jumping around. That's our club's mascot. His name stands for Monkey Astronaut Cowboy because he is all of those. Yeah, so we can give our game a name here, and we need to create a folder for it, which is a little annoying. Just gonna hit Create Folder, and at the bottom here we can hit Create and Edit, and that will open up the project. So the past workshops that I've given for the club have been in Unity, and whenever we created a project, we had to wait like 5 to 10 minutes for everybody's computers to catch up, because Unity is very heavy and it takes a long time to do pretty much anything. But Godot, look at that. What was that, 10 seconds? I presume that those of you who are following along, I presume it is taking a similarly short amount of time, perhaps. Now let's see, I will want to make sure that, oh, we got some new people coming in there, hello. But yeah, for those of you who are following along, I would like to make sure that we aren't falling behind, so I will be, asking occasionally to make sure that we're all at the same point. So prepare to raise those hands. Okay, well, you guys, are you planning to follow along with the workshop? Okay, good, because we just created the project. So get those laptops out fast. But yeah, I just want to make sure that we're all caught up, those of us who are trying to follow. So while the new people get their laptops out, I'm just going to give a little overview of the Godot interface here. So looking at it right off the bat might seem a little bit intimidating, but don't worry, it'll all become clear and intuitive once we get into it a bit more. So let's see, in the middle of the screen here is our scene view window. You can hold left click in here. You can hold sorry, I forgot my mouse, so I'm using my laptop trackpad. Oh, wait, you got a question? This is Godot. Okay, yeah, all right. The screen that pops up when you first open it, you hit New Project, and I'll just make a new project again because it only took like 30 seconds, right? Might as well. So I'm just gonna go ahead and if you guys will, give me a quick minute here to go through this one more time. So I presume you're on this screen. Now you're just going to want to go over to the side here, hit New Project. I've been provided with a mouse. Woohoo! Actually, never mind. I have no more ports available, so I will have to continue mouseless. All right, so we have a project. You're just going to want to enter your name of the project here. I'm just going to call it Mac Jump Game, and I already made one called Mac Jump Game, so I'm just going to call this Mac Jump Game 2. Hit Create Folder to make a little folder in your file system to hold the project, and then hit Create and Edit on the bottom. And now it'll open up the Godot editor. And something that's cool about Godot is that Godot is actually made in Godot. Like this watermark that pops up on any game you make in Godot also pops up on the engine, and that's because the engine itself is coded in Godot. Isn't that weird? Like, how do they do that? Anyways, so back to what I was saying. We have our scene view here. You can hold the middle mouse button to kind of move around there. Or actually, it might be right click. Well, try both and you'll figure it out. Again, I'm using the trackpad, so you can look around in this 3D space. Basically, this is your game world. This is your game's scene, and everything that happens in here. This is where our objects will show up, and then when we export our game, basically, it will be exporting what is going on in front of a camera that we put into our scene here. So over here in the top left corner, this box is the scene hierarchy tab, and we can start our scene off by choosing which of these options we want to start with. So our game is going to be 2D. So we're going to click 2D scene, and we'll see what happens here. Boom. Well, first of all, the view here in the middle has switched from 2D to 3D, which is cool. Now we can. Okay, yeah, you can scroll around in the 2D view. You'll notice at the top of the screen here you can actually switch between 2D and 3D at any point if you want. They're the same scene, it's just like, 2 dimensions versus 3 dimensions. Anyways, so initializing our scene has created here this thing here on the left called Node 2D. So basically in this hierarchy view on the side of the screen, all the objects that we create that show up in our scene are going to be reflected within the hierarchy. So the way Godot works with, game objects is everything is represented by a node. And it's a hierarchy in that the root node of the scene here will have as its children all of the nodes that represent the objects in the game. And, those nodes can have children, and so on, and so on, and so on. It's kind of like a big tree structure, basically. So if we wanted to create our player character to start with, we can right-click Node 2D, or you can also hit the plus button in the corner here, whichever floats your boat. I'm going to right-click Node 2D and hit Add Child Node, and now we can add a child. So we have all these options, all these crazy cool options. But what we want is something to represent our player. So we could, well, let's see here. There's regular nodes, there's animations, audio, multiplayer. Oh, that's pretty crazy. But what we want for our player is something simple. Now I'm going to put in, we're going to search for area 2D. And this is a type, well, if we hover over it, Godot will tell us what it does. It is a region of 2D space that detects other collision objects entering or exiting it. And that's really all we want for our project. Godot also has a built-in physics system, which is really cool. So if we searched, for example, body here, there's rigid bodies and static bodies, and those all have to do with the built-in physics system. But we'll be writing our own rudimentary physics, so we won't be needing that. We'll just need something that can detect collisions with other objects, and that's what Area 2D does. So we can just double-click this, or hit Create in the bottom there after selecting it, to drop it into our scene under our root node. And you'll see that, well, nothing has appeared in the, well, something has appeared, this little marker that we can drag around. And that represents our Area 2D that we've added because it doesn't have a sprite or anything on it right now. It's just an invisible, indeterminate object right now. So why don't we give it a sprite? Well, that reminds me, we got to download our sprites. So, I don't know if you guys saw earlier, we sent in the Discord server a Dropbox link where you can grab all the assets we'll be using for this project. So if you haven't downloaded that, you should do that right now. I'm going to do that right now. I've got it open. Oops. That was the title screen we were going to add to the game, but didn't have enough time to. Got our Dropbox open here. I'm just going to download it. My folder is downloading. Okay, I'll accept the cookies. And then I will open it up, and then I will unzip it with the archive utility, and then I will open up the folder. And yes, I am using a Mac. If you guys are using non-Macs, then don't worry, Godot will function exactly the same. But your folder unzipping process may not. That is up to you. So once you got that downloaded and got your folder open, basically you can just grab everything in it and drag it down into the bottom left corner of the Godot editor here, which holds all of our file resources. So just drop that in, and boom, a bunch of PNGs, bunch of WAV files, bunch of MP3s, pretty cool, and one font. Now, while you guys figure that out, I'm going to create some folders to organize these. You can actually right-click on the little folder icon here. Res is short for resources, and create new folder. I always like to make like a sprites folder, and then I can grab all the PNG files here, and then drag them all into that folder. It just always helps to have a little bit of organization in your file structure, you know, or. Well, it's your choice. So I'm going to make a sounds folder. How are we doing, by the way? Is everybody, anybody not caught up to this point right now? Not figuring out the files? No? Yeah? Oh yes. Don't worry. We'll spend a little bit more time here, so you guys have some time to catch up. You guys have the link to the Discord, or do you need that? I can put that up here if you like. You got the link? Okay. All right. But yeah, it is in the general chat. Yeah. It's an announcements and a general chat. I'm gonna finish dragging these into my folders here. Yes, link to a Dropbox. And lastly, I will create myself a little fonts folder. All right. How are we looking? Still need a couple minutes? Or all right. Well, for a couple more minutes, I will continue talking a bit about the question. The Dropbox folder or the? Oh, I just unzipped it in my downloads directory, and then grab everything in it, and then drop it into the bottom left corner of the Godot editor there. Yeah, no problem. Oh yeah, I forgot to say, we have plenty of time, so literally if you're stuck on something or if you'd fall behind, just raise your hand and we could just go back over it. It's, yeah, don't even hesitate. So, to finish our coverage of the Godot editor here, we talked about the left side, we talked about the middle, now the right side here is the inspector window. And you'll notice that if we click on anything in the hierarchy here, it changes. And what the inspector lets us do actually is it shows all of the attributes of a certain node in our hierarchy. So we can see that if we click on our root node here, it has some properties that we can look at. Pretty cool. Whoa, what do these mean? Who knows? Area 2D, that also has some properties here. Basically the way Godot works is every one of its game object classes inherits from the node2d class. So the node2d has a transform attribute here, which has the position of the object in the scene. In our case, it has an x and a y value because it's two-dimensional, 2D scene. Then a rotation, and then a scale. So everything that describes it's how it's shown. Then we have a bunch of other attributes that we don't really need to know what they do right now, but they have to do with its display on the screen. Our area 2D has, because it inherits from node 2D, it has in fact a transform down here too. And you can see as we grab and drag it around, it reflects there the X and Y position. If we wanted to rotate and scale it, it wouldn't really visually show much right now because we don't have a sprite on it. So, anyways, how are we doing now? Is there anybody who is not caught up? Are we good? Good? All right, let us continue. So we're going to give our player here, and we can actually double click this node here on the left. We can rename it to player. Pretty cool. And now we are going to add a sprite to it. So in order to give this node a sprite, we're going to add it as a child object. So we're going to right click it, hit add child node, and then we're going to search here for sprite. And let's see, we got 2D, sprite 2D, looks right, that's what we want. It's not going to be animated or anything, so let's just choose the regular one. You double click that, and boom. Now because sprite 2D is a child of our player object here, it will move alongside the player object. It's like stuck to it now, which is what we want because we want the sprite to represent the player. So right now the sprite doesn't have any visuals because we need to give it a sprite. We need to drop a PNG file in here. So we go down to our resources, open it up, and I made my folder, so I'm going to look in my sprites folder, and we want this mac.png file. So you locate that in your resources folder down here on the bottom left, and go grab it and drag it all the way over to the texture slot here of sprite 2D that has popped up in our inspector. As you can see, it says empty right now, but as soon as we drop that PNG file in there, boom, we have sprite. There he is. Now you will notice that he's a bit fuzzy right now, and that is something that happens with pixel art in most game engines. When a texture is imported, it's kind of filtered in such a way that makes pixel art a little bit blurry. So we're going to take a little bit of a detour to make him sharp as a tack. We're going to go up to the corner here in our top left corner and go into our project menu. Now I think on Windows it'll look a little bit different in the top left corner, but you will have a project menu. Click that, go into project settings, the first option here under project. And project settings in Godot has a handy little feature where you can search for certain settings, which is what we want to do. We want to look for something called default texture filter. So if we search just in this bar default texture, and then we see here under rendering and textures, we click that, and here we have default texture filter. So we want to change this from linear to nearest, and pretty straightforward. And we close this window, and boom, he's sharp again. Let's go. So, how are we all doing? Did we make it through that explanation, or shall I go through it very quickly again? Show of hands. Who needs another one? All right, another one. Project here in the top left, and then project settings, which is right underneath it. And in project settings here, there's a search bar right at the top of the window. We're going to search default texture, and what's going to come up is rendering here. We're going to click textures, and then it's going to show here default texture filter. And we're going to click here on the drop-down menu and change it from linear, which is what it is by default, to nearest. And what that does is it makes it so our pixel art by default will no longer be all fuzzy. Now we can just close this window, And there we go. All right, we good to move on? I will take that as a yes. So we have our player, we have our sprite. I'm thinking we want to add some controls to our player to start off. So, well, let's see. In order to make our player move, we are going to need to somehow capture, keyboard input and pass that to the player object and somehow modify their transform position value here, because you can see it'll move them left and right. And we can do that through a script. And in Godot, to add a script to an object, for any given node, it can only have one script attached to it. You kind of go over, click the node, go over to the inspector on the right, scroll all the way to the bottom, and you'll notice at the very bottom there is this little script option, empty by default. So we want to create a new script to attach to our player. We're going to click the empty box here next to script and hit new script. Now it is automatically suggested that we name it player.gd, which is short for GD script, the Godot's built-in language. But we're going to elaborate on it. Let's just call it player controller, It's being specific is good. Then we can just hit create, and it will automatically attach that script to our player and then open it up in Godot's built-in code editor. Pretty cool. You'll notice up here on the top of the editor, we can switch between the code editor and the scene view just with one click of a button. Very nice. So in the script view here, there's this little box on the left that has all of the scripts in our game, which right now is just one script, the one we just created. So let's get to editing that. Oh, first, as you can see, we've got a few default methods here that come with every new script that we create. We got the ready function and the process function, and they also come with these handy little descriptions. Ready is called when the node enters the scene tree for the first time, which basically means when the object is created. And for our player here, who we have here in the hierarchy right now, that will be called as soon as the game starts, basically, as soon as the player loads in. And the process here is called every frame. And this parameter here, delta, that gets passed in is the elapsed time since the previous frame in seconds. So it's going to be like 0.0031 something, something, something. And that will come in handy later, but for now we don't need to worry about it. So I presume you may already be able to see the similarities between GDScript and Python here. Have any of you never used Python before? All right. Well, I suppose I will be nice and slow. So I'm hoping that we're all able to follow along here. So the first thing we're going to want to do is add some variables that define our move speed. Because we want to be able to tell our player how fast they're going to be able to move left and right. So let's go ahead and do that right now. To define a variable that's going to be accessible throughout the whole function, or throughout the whole script, we're going to use the var keyword, and then we're going to give it a name. The Godot script editor is very quick with highlighting errors, so it may tell you in the middle of typing an expression that your expression is wrong, but don't worry. Just finish it and then give it a second, and it'll figure itself out. So let's give it a name. We're gonna just call it x move speed, and just like in Python, convention with GDScript is all lowercase with underscores between words. So that's how I'm doing it. You can do it however you like. And in order to give this a type, basically GDScript is also like Python, where variables don't have to be given an explicit type. Except it is handy in GDScript to give your variables a type, because if you don't, then GDScript will not be able to use that variable in its built-in code completion suggestions, which can be really handy. And well, it makes sense if you think about it. If you have a variable and the compiler doesn't know if it's a float or an integer or what, if you're typing out an operation that needs a float, your code suggestion is not going to. It's not going to. Sorry, I lost my own train of thought here. Point is, it's good to give them types just so that you can have code completion later, which is really handy. So in order to give a variable a type, you, right after the name, space, colon, space, then the type. And we can actually give this variable a default value or assign it right away with the equal sign. And let's give it, well, that was a good time to mention actually that Godot, its units, as we can see in the scene view, if we check our player here again and then move his position around, you can see that the units are pixels. So we're going to want to give this this move speed value, we're going to want to make it pretty high. Because in some other engines like Unity, 1 in terms of movement and position is equal to 1 meter. So you're going to want to keep that in mind. So let's just make it like 150, just to start with. And actually, we're going to add one more thing to this line. We're going to add an @export tag. And what this tag does is it will make this variable accessible in the inspector window. So if we go back to our player here, we click him in the hierarchy, and then look over the inspector on the right. At the very top, now we have our player controller script and our X move speed variable. So we can set it to whatever we want from outside the script, which can, come in pretty handy if you're doing prototyping. Testing a whole bunch of values out really fast. But let's just leave it at 150 for now. So, how we all doing? We got our first variable down? All right. No questions? All good? One question? What's up? In the, did you define it up here in the script? Found it? Okay, nice. All right. Let us continue. So now let's get some actual movement going here. So in process, which as we recall is called every frame, we're going to add an if statement. We want to check for input. We want to check if the player is holding down, say, the left or right arrow keys, and then we want to move our guy based on that, right? So the way we check for input in Godot is, well, there are a couple different ways, but the way we're going to use today is using the input class. So input with a capital I, dot is underscore action underscore pressed. This is a built-in method that basically it is true whenever a given key is held down on a frame. And input has a couple different methods for capturing input. It has is action just pressed, let's see, which is like, was it pressed down right on this very frame? Is action just released? Was it just, released on this very frame? Blah, blah, blah. But is action pressed is the one we want. And it will call every frame that key is held down. So it takes a string as input. And let's say left. We want to, when the left key is held down, we want our guy to move left. So let's do that. And if statements in GD script, like in Python, and with a colon, and no brackets or anything necessary. It's all based on indentation. So now, in order to make our character actually move to the left when we hit the left key, we need to access the player's position value on their transform here. So the way to do that within a script is actually really simple. Every value that is visible in the hierarchy here on the right, we can literally just access it by typing it in the script. So position here just references our transform position in Node 2D. It's basically the same as saying like self dot position. That's this value. And the type of position is a vector 2, which is just basically a pair of values, the x and the y here. So when we want to set our position to something, we're just going to go position equals, and we need a new vector 2. The way we do that is just by typing vector 2, open close brackets, and then in the brackets we need to put in an x value and a y value. So, well, actually, we've gotten a bit ahead of ourselves because when we want to move left, our x movement, our horizontal movement is going to be negative, and then if we want to move right, our horizontal movement is going to be positive. So if we do this position setting code every time that we want to move, well, it's just going to be a little bit messy code-wise. So we're just going to do something a little cleaner. We're going to declare, before we go into all these if statements, a variable for our x underscore movement, which is going to be our movement on the x-axis this frame. We're going to make it 0 by default. Then we're going to copy this line, save it for later, and just set our x underscore movement to, and it's left, so negative x underscore move underscore speed. All right, pretty straightforward. Now we're going to copy this whole block, paste it, and put a right in it instead. And then take away this negative because we want x move speed to be positive. All right, so now we haven't actually done any assigning to our position value, which we want to do now. Now that we have the value of our x movement on this frame saved into this x movement variable that we've created, we're going to now get our position, set it to a new vector 2. And so how do we know which x position we want to set here? Well, we can get the x value of our position by typing position.x, and we can get our y position value by typing position.y. But we want to add that movement value to our x position, right? And we can do that by doing position.x plus x underscore movement. Now, this is where this delta variable is going to come in handy. So if you think about it, process is called every frame, right? So if we're adding a flat number to our position every frame, imagine if you have, you know, a top of the line PC that gets 200 frames per second versus like a 20-year-old PC that gets like 10 frames per second. That slow computer is going to be moving 10 iterations every second, but your new computer is going to be moving 200 iterations per second. So if you just had a flat value being incremented to your position every frame, then your game would be running way faster, and not just in like a quality perspective. Like your character would be flying around the screen on like a new PC and crawling like a snail on an old one. So, oh, question? Sorry, what's that? Anything before the x? Oh, yes. Is it? Oh my goodness, wait, there's a bit of lag on the screen, I just noticed. Oof. But yeah, there's a minus here in line 16 before x move speed, and there is nothing on line 19, so we want it to be positive. Yeah, so. Anyways, in order to make the speed of our character consistent across different frame rates, all we need to do is multiply x movement by delta. And that does it. So if we were to open up our game and test it, which we can do right now by going up to this play button in the top right corner of the screen, we click that. Oh, no main scene has been defined. It gives us the option to select the current scene, so we can just hit select current. And then we need to save our scene, so I'm just going to call it main, and it'll save in our folder here down in the bottom left. Is it save? And it will run our game in this tiny window. Okay, well it seems something's gone wrong. And I think I know what it is, because we have our character in the scene, but we don't have a camera to show him. So let's go back to our hierarchy here. Click the root node, right-click the root node, and hit Add Child Node. And then in our nodes list, we're going to look for camera. And of course, camera 2D is the one we want. So let's just double-click that and add it in. And if we go back to our scene view, because we're still in the script view, we go back to our scene view here on the top, the 2D one. And if we zoom out a little bit, and we zoom out a little bit more, and we zoom out a little bit more, we can see the box that our camera is going to be displaying. This pink box around here. So now if we run the game, hit that play button. There's our player. Except actually, now this bottom part of the screen here, it's the output console. And when you run your game, you can, output stuff in there if you want to do print debugging. And it also tells you when you have errors. And it looks like we're accumulating quite a few. So let's see what those are telling us. We can close our window and then go into debugger and look at the errors. The input map action left and right does not exist. That makes sense. So when we, in our script, did is action pressed left and right, Godot doesn't actually know what we mean by left and right. We have to tell it what we mean by that. We have to tell it which keys to map to the actions left and right. So before we do that, how are we all doing? Anybody falling behind? All good? Yeah? Line 21. We set position here is referring to the player, the position of the node to which the script is attached. So this script is attached to the player object here in the scene. So when we call position, we're altering the player's position value in the scene. So this value right here. So when we, it's a little bit hard to see, zoom so far out, but when we change it, we're going to be moving the player left and right like that. We're just changing it through the scene. So the values we use are just, we're setting the x to the original x plus our x movement value, which is going to be positive if we're moving right, negative if we're moving left. And then we multiply it by the time since the last frame, which is a bit complicated, but all it does is make it so on different computers with different frame rates, our character will move the same, like independent of the frame rate of the computer. So does that answer your question? Great, okay. So now if we test our, no, we still have this error to deal with. So let us assign some input. So if we go up to the project view in the top left corner here, go back to our project settings, and what have we got here? There's a tab called Input Map. So click that, and there's nothing here in this action list right now, but there is a bar for adding new actions. So we defined left and right in our, or we didn't define them, we're using left and right in our script. So we want to create an action called left, and hit add here, and an action called right, and hit add. And while we're at it, we're going to want a jump key later for testing out our, our player's bouncing ability. So let's add another action for jump, just while we're at it here. We're going to add that. And in order to actually assign a key to these values, we just go over here to the plus button, and then right now it is listening for input. So you could just look through these menus for the key that you want to assign, or you could just press, let's see, left, want our left arrow key, just click the left arrow key, boom, it has detected left physical or left Unicode, which is our left key, left arrow key. And now we can just hit OK to add that. Same with right, hit the plus button, hit the right arrow key, hit OK. And then same with jump, we're just going to use our space bar, standard jump key, hit space bar, detects the space bar, we hit OK. And now we have our inputs mapped. So, how are we all doing? Anybody left behind? Got our inputs mapped? Okay, great. I will take that as a, we are good. So, now if we run the game again, we should not get these 2,500 errors. Click our little play button. We're good, no errors. But now, why don't we try pressing the left and right arrow keys? Our player moves. All right, got a question? You want to go into your hierarchy here, and then under the root node, you're going to right click and add child node, and then search for camera, and then just double click camera 2D when that pops up. Just add it to the screen. The scene and the screen, I guess. And this is the second one I've added, so I'm going to delete it. But yes, Yes. So in GD script, just like in Python, indentation is what determines. Like I would probably get that error if I. Hmm. Well, let's see. We got expected indented block after an if statement. Unindent doesn't. Well, let's see. Sorry, I wish I could help more. There's all kinds of indentation errors you can run into. You just basically want to make sure that all of your code is. You got to use a tab to indent. If you use spaces, it'll get upset. You'll get a mixed use of tabs and spaces for indentation error. You know what? We're getting to oh geez, almost 8 o'clock. Why don't we take a 5-minute break, and I can come in and catch people up who are behind, and then we can get back into it after 5 minutes. What do you guys think? Yeah. All right. Oh, what's we got a snacks? Oh yes, we have snacks. If you are hungry at all, please feel free to take one. They're in the back there on the table. Pizza will be coming in there later though, so leave some room for that. All right, we will be reconvening at, let's say, 8:01 p.m. All right. Please return to your seats. We will be continuing the workshop momentarily. Apologies that break took approximately 10 extra minutes than we thought it would. Turns out a lot of people were running into issues, and makes sense, because as we all know, code can be very finicky, and there are so many mistakes that you can make. There's like a 100% chance that you're going to make one of them at some point whenever you try to make anything. So, let's see, where were we? We just added horizontal movement. Let's add vertical movement to our player. You know, up and down, pretty cool. Let's think here. So, we don't need any kind of like crazy extra physics library for this. We want to make our character be able to jump and then fall back down. So we're going to create some extra variables up here at the top of our script. We're going to use the export tag on them again. They're going to be floats again. We're going to create a jump underscore force variable, a float. And just trust me here, we're going to set it to negative 750 to start with. We're going to export another variable, and we're going to call it gravity underscore force. Another float. And just trust me here, it's going to be at 750 positive. And this is a good time to mention that Godot's position values, so as we learned just now, negative on the x-axis is left, positive is right. But when we're talking about, up, down, the y-axis, positive is down and negative is up, which is, that is something that varies very much on different kinds of game engines. For example, Unity uses, positive is up and negative is down, which kind of threw me off when I was learning Godot. So we have to keep that in mind. So we got our jump force, negative 750, our gravity force, 750, and then we're going to want a private variable, which is to say we're just not going to use the export tag on it, called y velocity. Oops, gotta make sure we're using the underscores here. Make that a float, and it's going to start out as 0, and this is the value that we're going to use to track our character's velocity on the y-axis between frames. So, let's just add some code here to get gravity working. So gravity is a force of acceleration, right? So we want to add it to our velocity every frame. So, we're going to get our y velocity, and we're going to add, so plus equals, our gravity force. Except remember, we're going to want to multiply it by that delta value. Now, we're going to want to apply this movement in our little operation or expression down here where we're changing the position of our player. We're going to, instead of position.y, we are going to want to set it to position.y plus y underscore velocity times delta. And you may be wondering why we're multiplying the gravity by delta and then multiplying our velocity by delta again. And it's just some math stuff. It's because gravity is an acceleration, like squared, so you have to multiply it by time twice. I don't know. Just trust me on this one. So that should cover our gravity. If we test the game right now, yeah, actually, you know what? I'm going to try to make the screen in the middle here a little bigger so that you guys can see the whole expression at once, because it's, having to scroll left and right. It's got to be hard seeing the code like that. Okay, I can't actually expand it very much more than that, so I'm very sorry. I hope you guys are able to follow. So yeah, you want your position y to be y underscore velocity times delta. You want your y velocity plus equals gravity underscore force times delta every frame. We all good? Question? Wait. This error? This error? Right, you are. We will actually need this box later, though, so... well, we can leave it out for now. This is... okay. We almost can show the whole expression. Great, thank you for that tip. So let's continue. Let's try out our game. We're gonna hit the play button, and there he goes. So our gravity works. How are we all doing? Is our Mac falling off the screen? Question? Up a little bit, absolutely I can, yes. To our declarations. So next we are going to be adding our jumping, or I suppose it'll be bouncing, because in the final game we're not going to be, jumping on command. It's going to be like you have to bounce off platforms kind of deal. But anyways, let's go back to our process function here and copy the input block here, or one of them, doesn't really matter which one. We're going to copy it and then paste it, and we're going to change right to jump here. So then this is going to register, this block is going to register if we press the space bar. But do remember what I said about is action pressed. That's going to register every frame that the space bar is held down. So we actually want to use is action just pressed, which will only register once, the instant that the space bar is pressed down. And then, well, let's create the function that we want to activate first. We're going to create a new function that will make us jump into the air. So to create a function in GD script, we're going to go all the way down to the bottom here. We're going to use the keyword func, and we're going to call it bounce. And no parameters, colon, and then here we can define our function. And so when we bounce into the air, basically the only thing that we're doing is setting our y velocity to that jump force. Very simple. So just y underscore velocity equals jump underscore force. And actually that should be it. That should we should now have full control over our character. Of course, we did just map the bounce function. Oh wait, sorry. We got to map our bounce function to this input. So let's get rid of this expression here and put in bounce. And that'll activate this function whenever we hit the space bar. Pretty cool. So now if we were to, oh wait, the game's still running. You can press this box, stop button, to stop running your project. If we hit that play button again, we should, yep, hit spacebar, he jumps. So now we have vertical movement and horizontal movement. That is our controls. Although, of course, later we will remove the, space to jump thing, because that defeats the whole purpose of, trying to stay up by bouncing on platforms. But it's for debugging purposes, it's for testing purposes, and we have now confirmed that it works. So, are we good? Anybody, any questions, any trouble? Anyone want me to show any specific parts of the code here? Yes? Falling out of the screen? Yeah, that's because of the gravity. Yeah, I mean, check it out. And then if you press spacebar a bunch, you should come back up, because... Uh-oh. Well, I mean, if you have the code correct, oh man, I wish. See, the one nice thing about, I thought it was very cool that Godot has its own built-in script editor, because, Unity, and I believe also Unreal too, you have to use a separate script editor that whenever you want to edit a script, you have to, wait for it to open, and it takes a while, and it can be kind of annoying. But it does take up the whole screen, so you can see your whole script at once. Well, is it that broken? Anybody else having any trouble? It's looking like we're having a bit of trouble. What's up there in the back? It's not jumping? You gotta jump, we got it hooked up to bounce. If I click full... Oh my goodness! You're a genius! Alright everybody, crisis averted. Absolutely. It's seeming that we're having a couple more problems. Downwards? Cannot. Maybe. Okay, you know what? We're going to take a couple minute break right now so I can go and help out the people who are having immediate struggles, but don't worry, it'll actually just be a couple minutes this time. 1 second. Thank you very much for your patience. All right, everybody. Thank you very much for your patience. We are all... Oh. Wait a minute. Okay, wait, one more second. It's 8:30, guys. The pizza's here. Okay, well, I think we're gonna have to extend this break by another, let's say, 15 minutes. You know, let's say, well, 15 to 20 minutes, so that we can all grab some pizza. Thank you guys for putting up with me so far, and I hope that you will stay to continue this workshop after some za. So, let's get some pizza. Hear ye, hear ye. So, nice 20-minute break. Well, to let you guys know, we are running a little behind schedule. So the final product we end up with probably will be a little reduced compared to what I showed at the start. So prepare yourselves for that. But I'm hoping that we will be able to get through, the main mechanics and have ourselves a playable little game by the end. So with that said, I hope you've enjoyed the pizza. Let us get back into it. So, I was informed that you can't actually scroll out of this code view. I'm just trying to find the right scroll level that, it's still visible at. And my Mac is a little slow also. So if you'll give me just one moment. Is that still visible for you guys? In the back there? Good? You can still see the code? Still read it? All right, nice. Bigger? A little bigger? All right. It's all right. It's a little sensitive. I'm trying to zoom in with the trackpad. I can't. It's not zooming in. No, I can't. I can't allow that. Okay, well, Control plus, good idea. In this case, Command plus. Yes. Okay. Yes, Maylin. That's our VP bilingual back there. So, let's get right back into it. So we finished the controls. Next up is some rudimentary game logic. So our game is basically going to be, you're trying to stay in the air, you're trying to keep bouncing on platforms, and then if you fall off the bottom of the screen, you're dead. So what do we need right off the bat? We need some way for the player or the camera to follow the player as they move upwards. We need some way to detect when the player has fallen off the bottom of the screen. So here's what I'm thinking, all right? Let's go back to our scene view here. What I'm thinking is, well, actually, you know what? Uh-oh, wait. Okay, yeah, okay, from here on out, I'm going to be maximizing the script window a lot, so keep that in mind. It might get a little confusing, but yeah, you can always switch between these views on the top, and when I zoom in, yeah, just keep in mind this is the basic interface, and yeah. Okay, all right, game logic. So here's what I'm thinking. We're going to have an object in our scene view, and it is going to be a marker for the middle of the screen. And it is going to have, as its children, the camera. The camera is going to follow this middle scene marker, and it is also going to have markers for the sides of the screen and markers for the top and bottom of the screen that are going to follow this root middle node. So it'll basically be the camera, the middle and bounds of the screen will all be able to move as one unit. Then what we're going to do is just have it follow the player up, but not back down. So it's not going to follow the player completely, but it'll follow them up, but it'll keep going up, and then if the player falls off the bottom of the screen, that's game over. That's what I'm thinking. So if you didn't get all that, don't worry, because we're going to go through it like slow and make everything one by one. But that's the philosophy. So under our root node here in the scene view, let's right-click it, add child node, and it's just going to be a basic node 2D. We're not going to need to add anything to it. We can just double-click node 2D, and let's rename this to screen middle. So this is going to be our marker for our middle of the screen. And remember, we're going to want to drag our camera 2D here. We're going to want it to move alongside this screen middle marker. So we're going to want to grab that camera 2D and drop it onto screen middle to parent it to, drag it onto screen middle to parent it to screen middle. So you can see the tree hierarchy of the scene. The camera is now a child of our screen middle marker. And what else do we want as a child of the screen middle marker? Well, we want markers for the sides, the top and bottom of the screen. I already mentioned we will be using the screen bottom marker as a reference for if the player drops past it, it'll be game over. The side markers we'll be using to make sure that the player doesn't move off the side of the screen, because that's possible right now. So let's add to our screen middle here. We're going to right-click it, add child node. Again, another node 2D. And we're going to rename that to screen bottom. And really quick, let's just set that location so that it really is at the bottom of the screen. And so we have in our scene view, we can see the bounds of the camera. We can see the edges. This pink rectangle is what the camera shows on the screen. And we want this screen bottom marker to be right around the bottom there. So we can actually just kind of zoom in a little bit and then grab it. We can click it to grab it. And then just kind of drag it down so that it's right at the bottom there of our camera. Perfect. Oh, well, it's not, perfect. We can actually check out its transform here, and if we want it to be right in the middle of the screen, keep it neat, we can set its X position to 0, and the screen is actually exactly 648 pixels tall, so 324 is the exact correct Y value for the bottom of the camera screen. So we got that marker done. We can hit Control D or Command D if you're on a Mac to duplicate the screen bottom marker, and then double click the resulting node. We can rename that to screen top. And so now we already know that the bottom of the screen is 324 units away from the center. So we can just make this, we can click screen top, go over to the inspector, and we can see, we can just change the Y value to negative 324. And now it's at the top of the screen. Great, we're halfway there. Let's duplicate, let's say screen top this time again. Control D or Command D. Rename it to, let's say, screen left. And now let's go back to the transform. Well, here's the thing with this type of game. The game that we're basing this on, Doodle Jump, as you guys may or may not have heard of, was an iPhone game, and the mechanics we're using are kind of designed for a narrow-ish type screen. So what we can do is restrict it so that even though the camera is, the game window is pretty wide, we can add some like black boxes on the sides, like, aspect ratio-ish type deal to box the game into a little corridor kind of shaped play space. So why don't we put our screen left here? We can move it to where we kind of think we want the left side of our screen to be. So I'm gonna grab it and, I'm gonna click screen left here on the side. I'm going to grab it, and that's the camera. Okay. The issue with having all of these things, like multiple things in the middle of the screen. Oh, wait a minute. Nope, it's at the top of the screen because we duplicated screen top. So it's up here right now. I'm just going to, instead of grabbing it and moving it, which would take a little while, I'm just going to go into the inspector, set the Y value to 0 to set it back to the center of the screen, and, hit enter there, so it's back to the center, and then zoom out, and let's see, about there. That looks good. So now we can see the inspector. That's 204 pixels to the left of the center. And now if we select it one last time, hit Command Control D to duplicate it, rename it screen left, and go back to the transform and the, screen right. It's already screen left, screen right. Grab it here on the, go to the inspector, go to the transform and change the X to positive 204. And there we have our 4 markers for the top, the bottom, the left, and the right of the screen, and the middle, and the camera parented to the middle. So I know I did go a little fast there. Is anybody lost, or we're good? We got all our markers there, roughly around the edges of our screen. I will take that as a yes. Now these are going to be used in our script to write some game logic. So before we get into that, let's create an object to manage all the game logic. We're going to right click our root node here, add child node, just call it node 2D. Search for node 2D. We're going to call it game manager. And that's just kind of whenever you have, an object or a script that's responsible for handling the game logic, it's just kind of tradition to call it game manager. So let's go over here, select it on the left, go over to the inspector on the right. And all the way at the bottom in the script, it's empty right now. We're going to click that, add another new script, and default it to the name of the object, which is game manager. Let's just create it like that. And here's our second script. So yeah, if I open up the bar here on the side that I closed, you'll see that in this box here, it now has both the player controller and game manager scripts, which we can switch between as we like. But for now, we're going to be working on game manager, so I'm just going to move that out of the way. And I'm going to, well, I'm not going to full screen it just yet, because before we do anything else, we need to get references to the objects in our scene here that mark the edges of our screen. Because in this script here, this game manager script, this is where we're going to be checking in the update loop, has the player fallen down past the bottom of the screen? If yes, game over. And in order to check that, we first need a reference to the player's position, and we also need a reference to the bottom of the screen marker's position. So in Godot, it's pretty simple to get references to other objects in the scene. So from our game manager script, if we wanted to check, say, the player's position, or screen middle's position, screen bottom's position, we need to add a reference. So we're going to start with the onReady tag. And what this does is any variable defined with the onReady tag, it will only try to get the reference after the initial scene hierarchy setup is complete. And that's just kind of a technical thing, because if you tried to get a reference to a scene object before the scene hierarchy was all sorted out, it would just run into a bunch of errors. So it's basically just a technical thing. So whenever you want a reference to something as quickly as you can get it, like at the start of the game, you're going to have to use the onReady tag. So now this is going to be a variable. Let's get the player first. So the player, and well, let's not capitalize it. Player with a lowercase p. And that is going to be of type, well, what was our player? Our player was an area 2D. And yeah, the same type exists here in the script. And now we're going to set that equal to, so in order to get a path to this node, we need to use some built-in methods here. We need to use the, well, every node has some built-in methods. One is getChild, which you can pass a path to get a child node of that object. So if we were to, if we wanted to get the child player of our root node, which is what we want, we have got to use get_child, brackets, and then we need a path to our player, and we can actually get a path by right-clicking the player here in the hierarchy on the left, and then scrolling all the way down here to copy node path, or you can use Shift-Control-C, Shift-Command-C, and that will copy the path to this node in the hierarchy. And it's not going to be a very impressive path because player's right under the root node. The path is just going to be player, because that's the object's name in the hierarchy. And of course, we need to put it in quotation marks. It does take a string. Except we're not done quite yet with this reference. getChild calls on the node attached, that this script is attached to. So if we were to call getChild right now, it would look for an object called player that is a child of our game manager script, which player isn't a child of the game manager, it's kind of a sibling node to game manager. So we can get that by first going up one level with get_parent. So basically this just goes from game manager to our root node and then down to player. So that is how you get, oh, wait a second. Cannot pass a value of type string as int. Okay, well, I seem to have run into a bit of an issue here. Hold on a second. Okay, you'll have to forgive me for a second while I do some covert Googling on my phone. See, at this point, I should mention again that I have only been using Godot for like a week. So some of the context gets a little bit, you know, take this time to, you know, catch up, make sure you have all your variables in order, all of your, you know, your screen markers are all on the edges of the screen properly. Yeah. Well, you'd think so, but when I coded this before, I definitely used a string, so I think I'm just using the wrong method here. And some of them use like an integer to access it. Okay, well, I may or may not have consulted the internet on my phone just now, and it's using the exact same construct. So we have maybe, yeah, what was that? Okay. Thank you to Joanna for informing me that it is get node. Okay. Apologies, guys. Hopefully that's the last time that my memory fails me during this workshop. Yeah, so getChild uses a integer, which is basically the index of the child in the parent's list of children objects. But getNode uses the path, so that's what I was trying to think of. Anyways, we're going to copy this and get ready for some hardcore pasting, because we are going to need references to the middle, bottom, top, left, and right of the screen. So I'm going to paste one and then call it screen middle, and then getParent.getNode. Well, the path to screen middle, it's another sibling of game manager, so the path is just going to be screen middle. We're going to copy this line again and paste it 4 more times. And I'm just going to go through at a leisurely pace and change these all to bottom, top, left, and right. You know, just a nice little break from all of the, you know, crazy frantic coding we've been doing up till now. We do have to take into account now the fact that screen bottom, top, left, and right, those other markers we made, they're all children of screen middle. So their path, their node path is going to be a little bit more complicated. We can actually get one here. If we look looking at screen bottom, we can right-click it, check the copy node path, and see what it gives us. If we paste it here, screen middle / screen bottom, because it's a child of screen middle. Fair enough. And now if we edit these other strings, you'll see that it actually, it suggests to you out of the children that exist for screen middle, which is pretty handy. So we want top. I'm going to go down there with the arrow keys. You can select these and then hit enter or tab to fill them in. Screen top, and then / screen left / screen right. Okay. Are you guys all with me here? Shall I give you guys a little while to catch up? We're good? We got our references? Okay, I'll take that as a yes. So we have our player, we have our size of the screen. Let's do the first thing that we were going to do. And in our process method down here, we're going to check if the player is below the bottom of the screen. Because if the player is below the bottom of the screen at any point, that means it should be game over, right? So remember, we can access the position of objects with the position variable. And the way we access the position of other objects is pretty simple. Our reference to player we called reference up here. We can just do player.position.y is greater than, and remember we want to use greater because in the world of Godot, greater is lower on the screen and a smaller is higher up on the screen. So if it's lower on the screen, then screen_bottom.position.y, then we want something to happen. So what do we want to happen on the game over? Well, probably you want to lose control of the player, because if you fell off the screen and then the game over text popped up and you could just jump back up onto the screen, that would kind of kill the tension, you know? So let's figure out some way to make that happen. So in Game Manager, we have a reference to our player. We can actually give player a reference back to the Game Manager. So why don't we add another variable here at the top? We're just going to make it a regular variable. It's going to be a Boolean, and we're going to call it game started. It's going to be a bool, and it's going to start as false. And this will also double as, you know, when we open the game right now, our guy just kind of falls right off the screen. We hardly have any time to react. That's kind of lame. So what we can do is we can have the game basically paused until maybe the player hits the space bar. Then the game starts. Then when they fall off the screen and it's game over, the game kind of pauses again. And we'll use this game started bool to make that happen. So let's pause for a second here. Let's go back to our player controller script. Oh, but first, let's make sure to copy one of these, you know, get node lines, one of these get reference lines, because we'll need to paste it and edit it a little bit to get a reference to game controller, or game manager. So let's go back to player controller, go up to the top of the screen, and among our variables over here, paste it in, and instead of player, we want a game manager variable, and instead of get parent.getNode player, we're going to want to do get parent.getNode game underscore, oops, not game underscore manager. We used game manager with no space and capitals. So that is our reference to game manager from player controller. And now we are going to want to here. I forgot to full screen the script earlier, but I will do it now. We're going to want to use that reference. We're going to go into the player controller's process function here. And so these if statements here are what allow us to move. So if we gate these behind an if statement or something, we can control whether the player is able to move at all, or if the controls just do nothing. So why don't we indent this whole block and add at the top an if statement, and we're going to use the game manager's game underscore started bool that we added. So if that's true, we're going to allow the player to move. If it's false, we're not going to allow the player to move. So if game manager, because remember we added a reference right up here to the game manager, if game manager dot game underscore started, and then our colon here, then we're allowed to move. So if we save everything, wait, seems I forgot a indentation in the game manager here. Hold on, give me just 1 second, just one little second. Oh, it's because we never finished this statement. So let's, well, remember what we were talking about before. If it's game over, we want the player to freeze, and now we've added the ability to freeze the player's movement by setting game started to false. So if player.position.y is greater than this, if the player has fallen off the bottom of the screen, we set game started to false. The game is no longer started; it is stopped, and now the player should be unable to move. So let's just start the game and try that out. Let's give it a little try. So right now, okay. Well, we got a little bit of a bug here, a little bit of an error. Oh yeah, here. Okay. The issue is that. 1 second. No wait. What? Oh yeah. What? Yeah. Area 2D here is actually supposed to be a node 2D. Since we copied it over from Game Manager, we forgot to change that to account for the fact that our player is of type Area 2D, but our Game Manager is not. It is just a regular node, and we gotta account for that. So, one question. What's up? Yeah, those are correct though. Those should be node 2Ds. Are they not? Did I mess that up too? Wait a second. You're right. Yep, you're right. These should also all be node 2Ds. We all make mistakes. Good that we caught it. It's something that's easy to fix. So we can just go back through all of the screen markers that we defined and make them node 2Ds instead of area 2Ds. And now we should be bug-free. Emphasis on should, because obviously it's never that simple, but... All right, are we all good? I'll take that as a yes. Let's hit the stop button to stop our error-ridden test run and start a new, hopefully errorless test run. Okay, so our player is still falling. We didn't really get the time to figure out if we can move him or not, though. So why don't we, well, let's start it again and try hitting the space bar as fast as we can, because if we hit it right away and he doesn't jump back up, then we know we've succeeded in making the controls inaccessible while game started as false. So let's hit that again. He didn't move. That's good. And the issue, of course, now is that when we don't really have a way to start the game, because our game started bool starts as false. So let's change that. Let's add some way to start the game. Now, we can just go over here to the process function in Game Manager and add another if statement. And remember how we checked if the spacebar key was being pressed? We used input dot is action just pressed, and then jump, colon. And now we can set game started equals true. All right, so we should have something working here. The game starts when you jump, and it stops when you fall off the screen. Let's give that a shot. Let's see if our suspicions are accurate. We're going to start the game, and we still fall. So it's now occurred to me that we should have actually, there's one more line in our player controller that we should have gated behind that game started check. So let's go back to our game controller, or player controller, really quick. And then scroll down. And here we go. We want to gate these two lines also behind the if statement. So let's just grab our y velocity and our position setting lines and indent them one block forward. And now our player should be truly frozen. So if we hit the play button, ba-ba, Mac is frozen in the middle of the screen because game started as false, and none of these blocks activate if game started as false. Now, if we hit space, Game Manager should start the game. It did. We hit space, and we fell again, and now we've hit the bottom of the screen, and the game is frozen again. So, we're getting somewhere. All right. Oh, yes. Yes, absolutely. Why don't we take a few minute break here, and I'll come around and make sure everybody's doing all right. All right. One sec. See you in a few minutes. All right, guys. Sorry again for the interruption. So as you can see, it's nearing 9:30. This has we've gone significantly behind time. I regret to say. I hope that you guys have learned something so far about Godot. But if I must put it plainly, I don't think we're going to be able to finish the game tonight. So I have an alternate proposal. What do you guys think about making Flappy Bird? Woo, Flappy Bird! I mean, it's also a game. So we can keep everything we've got right now is all I'm saying. But we'll be pivoting the end product away from a Doodle Jump-like game to a Flappy Bird-like game, just so that we can hopefully have a complete and functional game by the end of this workshop. So thank you guys for putting up with me. Thank you very much for your patience. Let's get Flappy Birding. So we will be able to use all of the logic that we've built thus far, because you know Flappy Bird as well. Also, the game starts when you jump and it ends when you fall off the screen. So all we really need to add now is obstacles, which is nice because that'll give us a little a look-see into Godot's object spawning system, or instantiating, as is the technical term. So let's look back at our scene here. So if we check out our game, we can jump, we can move left and right. Okay, well now that I think about it, Flappy Bird you can only really move in one direction. But that's a moot point, isn't it? So what's the first thing we need to add? Hold on, I also need to think for a second. All right, let's get to those obstacles first. We're going to do a little bit of instantiation, a little bit of collision. It'll be a lot of fun. I'm going to unzoom out here. Let's go back into our hierarchy and let's just get right back into it. So we are going to have to improvise a bit with the sprites that we have here on the in our folder. So which of these seems most, vertical pipe obstacle-like? I think we're going to have to use this black square .png. All right, well, you know what? This is actually a great exercise because if you ever find yourself doing a game jam, something where you're pressed by like a time constraint to finish a game, you will often find yourself having to pivot. So, that kind of resourcefulness is very important for a game developer. So let's go ahead and go to our root node, add a child node, and we're going to create another area 2D, because remember, area 2Ds can detect collision with other area 2Ds, and we want to be able to detect a collision between a player and the obstacle. So we're going to create an area 2D under our root node, and we're going to name it, let's just call it obstacle. And let's go ahead and right-click it again and give it a sprite. So we're going to search for sprite 2D and add that. And we are going to give that sprite the black square.png texture. Awesome, right? It's a square. And we can actually just kind of grab the corners of the square to shrink it down to somewhat of a rectangle, because that's what we want. And remember in Flappy Bird, there was whenever you had to pass between a space between the pipes, so there was one on the top of the screen and one on the bottom, right? So let's kind of mimic that here. Actually, wait a second. We want to undo that because our obstacle is still in the center of the screen. So let's just make this a rectangular kind of obstacle. Let's make it, a little bit longer. Make sure to keep the sprite's center kind of centered over the center of our obstacle. And now let's actually add a hitbox, because we have yet to do that even for the player. You'll notice that the obstacle and the player here, since they're both area 2Ds, they both have a little warning triangle here, and if we hover over it, it says, this node has no shape, so it can't collide or interact with other objects. And in order to give them shapes, we're going to have to right-click them, add a child node, and we're going to add, let's search here, a collision shape. Collision shape 2D is the one we want. So double click that to add it. We want one as a child of our player object. So, well, right now our player is kind of hidden behind that big rectangle that we added. So in the hierarchy view, you can see this little eye icon. Every one of our nodes has it. Let's just click it on our obstacle to make it disappear for now so we can better see our player. Now let's go back to our player's collision shape, which is a child of our player object. And right now it doesn't have any shape defined, and in order to define a shape for it, we click the collision shape, go over to the inspector, and you can see that it has a field here called shape, which is empty. If we click on that, we get this whole bunch of options, but the one that fits our purposes here is a new rectangle, rectangle shape 2D, and that's going to give us a rectangular collider that we can manipulate. So click that, rectangle shape 2D under the shape field here, and you'll see we have a nice little rectangular collider here. We can grab the edges, drag them out to encapsulate our character, and that is our player done. They have a sprite, they have a collision box. Now let's add the same to our obstacle so that it can collide with our player. So obstacle, let's make it visible again, zoom out so we can see all of it. And now let's go to obstacle. In the hierarchy, we're going to right click, add child node, and it saves our search from last time, which is collision. So we're going to want to add another collision shape 2D. Just double click that to add it. And we're going to have to go through the same drill again, select the collision shape 2D in the hierarchy, go over to the inspector, click the shape field, and add a new rectangle shape 2D. And we've got our tiny little hitbox there, little rectangle. Grab the edges, stretch it out so it kind of roughly is the shape of our obstacle. And now, well, so remember Flappy Bird, the obstacles kind of occurred in pairs, right? You know, there were the two pipes and there was the space between the pipes. So let's actually, before we turn this into a mass spawnable object, let's kind of pair it with another of itself, and then kind of, you know, fuse them together into one object that we can then, you know, mass produce and respawn. So we can do that by grabbing our obstacle and hitting Control D or Command D to duplicate it. We can just leave it as, you know, named obstacle 2. And now let's grab the first one and move it down. We want to make sure that they are, oops, sorry, I'm still grabbing the collision shape, so I just kind of grabbed the hitbox and moved it. So let's undo that. And of course you can undo and redo with Control Z and Control Shift Z respectively, as with most softwares. Very handy in a pickle such as this. So we're going to go to that first obstacle, and we're going to, well, we can't just grab it with our mouse, so because there are like a billion things on that one spot, and if we try to grab it, it might register that click on any of the objects that exist on that one spot. So we're going to have to click the obstacle, go over to the inspector, look at the transform, grab the Y position value, and well, it'll take a while, but we're going to drag it down until it's respectably lowish to the bottom of the screen. And we want them to be of roughly equal distance from each other from the center of the screen. So let's say 240 on the y-axis. Let's grab the other obstacle and set its transform in the inspector over here. Let's set its y position to minus 240. Well, that's a bit of a small gap, isn't it? Doesn't look like our Mac can even fit through there. So let's change this value up a bit so there's more of a gap. I'm just going to go ahead and try out some values here. Minus 300. Minus 300 is pretty good, but I think honestly even a little, like maybe minus 315. Sure. And now let's go and make sure that the other obstacle, the first one, is similar distance away. We're going to change its y value to 315. And there we go. So we have these two obstacles that are, they've got a nice little space between them for our player to try and jump through. And now we want to make them reproducible. We want to make these into a spawnable kind of template object. So in game development world, one of these spawnable template objects is usually referred to as a prefab, and the act of spawning them is usually referred to as instantiation. So I'm going to teach you guys how to make prefabs and how to instantiate prefabs. Pretty cool, huh? So first of all, these two obstacles right now, they're not really linked in any way. They're kind of just both floating under the greater scene root. So we're just going to add another child node under the root node. It's just going to be a regular node 2D, and we're just going to call it obstacle parent. And then we are going to grab both these two obstacles and grab them in the hierarchy and drag them onto the obstacle parent to make them children objects of that parent. And boom, we now have this one greater object that we can drag around and make into a prefab and spawn as itself. So each one obstacle parent unit contains the two obstacles and the gap between them. All right, let's get prefabbing. So it's a pretty simple process to make a object into a prefab in Godot. Basically, I'm just going to go here into my file system really quick and add another folder, because I like to be neat. We're going to call it prefabs. And all we have to do to make this obstacle parent into a respawnable object is grab it with left click and drag it down and just drop it into the file system somewhere. I'm going to drop it into my prefabs folder, and now we are prompted to save it. And we can just save it as this. You'll notice that it's being saved as a tscn file, which is actually the same file that our scene itself is saved as. See, main.tscn, that's what we're in. And that's actually because Godot does something funny with prefabs and instantiation. Whenever you save a prefab or spawn a prefab, you're actually saving a scene, because a scene in Godot is just a node with children. So it's just kind of a cool little modular system, it's all nodes all the way down. So now that we've saved our obstacle parent in the file folder here, and make sure that that you actually have it in there before we, just make sure you've actually saved it. Let's just delete it. We can right click it here and go down and delete that node, get rid of it from the scene. And now we're going to spawn some of them. So remember that script that we were making the game logic in Game Manager? Let's go back to that script. Let's go to the script editor. Let's go to Game Manager. Oh, already here. I will now full screen it, and let's write some code. So the first thing we want to do is, remember we needed references to reference things outside of the immediate script. We will need another reference here, except the way that we get a reference to a prefab is a little bit different than the way we get a reference to another scene, another object in the scene hierarchy. We're going to want to, we don't need the onReady tag this time. We're going to create a variable. I'm just going to call it obstacle. It's going to be of type packed scene. And we're going to set that equal to preload. Then in brackets, you can see that it automatically suggests to us all of the files that are in our file system. And we're going to choose res://prefab/obstacleparent.tscn, or wherever you saved your prefab file. So select that, and this is what the end product looks like. This is our prefab that we've loaded in. So essentially we've loaded a template object into our script, and now we actually want to spawn that template object. So before that, let's define a couple variables to use when we're actually spawning these obstacles. So first we're going to want, say, a gap, a standard gap between the obstacles, right? So we're just going to, let's use an export tag for this so that we can change it in the scene editor later if we want to. We're going to call it a variable. Let's call it obstacle gap. It's going to be a float, and let's set it to, let's say, 500 pixels to start with. And next, we're going to want some kind of way to, actually, you know what? Let's just start with that. Let's keep it simple for now. And let's spawn some prefabs. So, let's think about this for a second. Flappy Bird, when you proceed to the right, the obstacles spawn kind of infinitely. So we need some kind of way to, well, either we could do the spawning at the start of the game, which, well, you can't really spawn an infinite amount of objects, right? So I guess that's out. So we're going to need some kind of way to actively keep spawning these obstacles in as we move to the right of the screen. So let's go ahead and add a couple more variables now to keep track of that. Good thing we have all those references to the middle of the screen, the sides of the screen, because we're going to use those to track the movement of our character so that we can decide when to generate the next obstacle. So let's think about it. The obstacle is going to be generated just off the side of the screen, to the right of the screen. Let's add a variable here to track the last generated obstacle position. And it's gonna be a bit of a mouthful. Last generated obstacle pause. It's just gonna be a float. And we'll use this to keep track of the last X position that we generated an obstacle at. Then we're gonna add one more, oh no, we have our obstacle gap already, so let's go down to our process function here. We don't need to set last generated obstacle pause to anything just yet. Well, first let's add a function to generate an obstacle. So we're going to add func generate underscore obstacle. Don't need any parameters. Let me think for a second. All right. So now we're going to get back to the whole prefab instantiation thing I was talking about. So the prefab we got a reference to, it doesn't exist in the scene just yet. It's kind of a template. And in order to spawn an object from that template into the game world, we're going to use an expression like this. We're going to use, we're going to declare a new variable. Let's just call it O. This is going to be a reference to the object that we spawn in the game world, and we can spawn it by using our obstacle prefab variable dot instantiate. And I don't know if any of you guys are using Godot 3 point something, because I believe that this is one of the things that changed in Godot 4. It's instantiate here, but in older versions of Godot, it's instance. So if any of you guys are using an older version, keep that in mind. So now we've created, just like that, a new instance of our two blocks with the gap in between them. Now we need to kind of move it to the correct place that we want the obstacle to be, which is right off the right side of the screen. So since the screen's going to be moving, we need some kind of dynamic reference to the side of the screen. Oh, we have that because of our screen marker that we made. We can use screen underscore right. So in order to set the position of this new obstacle object, we're going to go o.position equals vector 2. And the x position will be screen underscore right. And let's say plus like 100, or sorry, screen right dot position dot x, excuse me, plus like 100. And of course the y position will just be 0. So, well, right now it'll just be 0. So that is our spawning script right now. We have a function for generating an obstacle now we can put that to use with those variables we made earlier to actively and infinitely spawn those obstacles. So in our update function here, let's go ahead and add one more block, another if statement. We're going to say if the screen underscore middle dot position is greater than this variable we defined earlier, our last generated obstacle pause. If that is the case, then we will simply generate obstacle. So, and of course, once we've generated an obstacle at the new position, we're going to set last underscore generated underscore obstacle pause to screen middle dot position dot x. Oh, okay, we're gonna have to go back and change something here. We want to use screen middle dot position dot x here is greater than last generated obstacle pause. So, to recap, we have, as the middle of the screen moves to the right, it will generate an obstacle, then wait a second. Okay, sorry, missed one last thing here. We're going to have to add here in the if statement, we're going to check if the screen middle position dot x is greater than last generated obstacle position plus obstacle generation, obstacle underscore gap. Whew. Sorry if this is a bit all over the place. It's kind of a bit of an on-the-fly pivot. I'm kind of improvising these mechanics as we write them. So to recap, an obstacle will be generated across just off the side of the screen, and then as the player moves, the middle of the screen will move, and once we reach a certain threshold, another obstacle will be generated off the side of the screen, and that will continue infinitely. And so we have our infinite obstacle generation. And with this code, it should actually be almost functional. We just have to make the camera follow the player, or the screen middle follow the player's horizontal position, which we can do with one more expression here. We're just going to go screen underscore middle dot position dot x equals player dot position dot x. All right, so that was a bit of a coding marathon. How do you guys feel? Are any of you completely lost, or have we managed to stay somewhat caught up? Absolutely, I can scroll down. All right, looking pretty good. Thank you guys very much for, sticking with me. I'll give it a few more seconds for people to make sure their code is accurate, and then we're going to give it a shot. All right, I'm going to give it a play. All right, no errors, that's good. And remember, we set it so that the game only starts once you hit the space bar. So let's hit the space bar and start moving to the right. The camera, it doesn't look like we're moving, and that's because the camera is following us. But it also seems that the obstacles are not spawning. So something has gone a little bit wrong. But that's okay. Let's go back to our code really quick and see if there's anything outwardly obvious that might be, an error. So we're checking if screen middle position dot x is greater than last generated. Here's the issue. Wait, no, never mind. That's not the issue. It's last generated obstacle position plus obstacle gap. We have obstacle gap. It's 500. Let's go ahead back to our scene, and just as a debugging measure, let's change the obstacle generation gap to B. And remember, we can go to our game manager, and edit that field right here. Since we use the export tag, let's make that like 100. So just to make sure, you know, like it's not that we're not traveling far enough to generate the first object. They should be pretty frequent. So debug measure number 1. Let's go along and see if it's working here. Nope, still not working. So that means there's something wrong with our generation code. So let's take another look. You know, this is a good time to demonstrate some classic print debugging. So we don't know where the issue is here. We don't know if it's in our generate obstacle function or if it's in our logic here. But because it looks pretty watertight to me, but clearly something is wrong. So I'm going to do another, just a little statement here. I'm going to use a print statement. And what this does is when it gets to this point in the code, it kind of shoots whatever message we put in here out into the debugger. So I'm just going to put a message here saying, made it here. So if we reach this point in the code, then we know that this code isn't broken, the code after it is broken. So let's run it again. And keep an eye on the debugger down here, the output menu. We're going to be moving. Oh, look at that. So we are making it to that point. So our code for checking the movement of the middle of the screen and checking when we're supposed to be generating platforms is correct. Or sorry, generating obstacles is correct. But there's something wrong with our generation. So let's close that. Give it a check. So generate obstacle. All right, I figured it out. It just occurred to me, silly me, when you instantiate any prefab into an object in the scene, you have to add it to the scene by adding it as a child to the root node. And we can do that with just one simple line of code, get parent, because remember the parent of the game manager is the root node, dot add underscore child, O, because O is our obstacle that we made. And this should, because basically what was happening before is we were just kind of spawning that obstacle into the void, because with no scene parent, or root scene parent, it was not actually rendering in the game world. So let's try that one more time. And we should be getting a ton of platforms now since we set our platform thing. Oh, there's one. Okay, well, it's an improvement. We got one platform. So we know that it's getting here multiple times. Last generated obstacle position equals screen middle dot position, screen position, last generated obstacle position, plus obstacle gap. So this should be working multiple times, and I'm going to put that print statement back. I sincerely apologize for this, by the way. If I had known, well, let's just say for the next workshop, I'll plan a Flappy Bird contingency plan in advance so that we don't have to deal with so much debugging. So that method is still firing. There is still an issue with our obstacle generation, then, is what it seems to be the issue, because our debugger here is saying that we are making it to this point in the code. So generate obstacle is being called. Let's see. So we have dot position, screen dot right dot. Here's the issue. Okay, so one last very important and very frustrating thing with Godot is that every node 2D has two values that represent its position. There is an attribute called position, and there is an attribute called global underscore position. And you have to be really careful which one of these you're using in any given piece of code, because when you're referring to a node's position value, it's really referring to its local position in reference to its parent. So the local position of any of the root scene's children, so any of the like top level children, their position value will be identical to their global position value, because while position is relative to the parent, global underscore position is relative to the root scene node. And so it only starts mattering when you need the position, when you're checking the position of children of children. So because screen right was a child of screen middle, when we accessed screen right.position, that value was never changing no matter how far right we were moving, because the relative position of screen right to screen middle never changes. So by using global position, we are accessing the value that actually is changing, and that's its position in world space instead of local space relative to its parent node, screen middle. So with just that simple one change in our code, it's really going to work this time. Check it out. All right, well, we've definitely got something going here. So let's remember we were going to add those blocks on the side of our screen to make our kind of aspect ratio iPhone-like. Let's do that because our screen right, left, all the borders of our screen are dependent on that blockage on the right and left. So this is what the black square graphic was intended for in the first place, was to go back to the root scene node, add child node, just add a sprite 2D, and we're just going to call that screen barrier. And now we're just going to go to our sprites, grab black square.png, and drag it onto our texture for screen barrier. Kind of drag it up so that it covers the whole screen vertically, and then drag it to the left so that it just matches up with the side of our screen that we marked with our screen left there. And lastly but not leastly, we're going to drag it on top of our screen middle to make it a child of that whole bunch of items that are all going to move together with the camera. And of course we need one on the right too, so let's use Control D, Command D to duplicate it, and then go to the transform and inverse this so that's positive 461. And now we have our kind of iPhone-ish portrait style screen. And now if we try again, we will see that the platforms are correctly generating just off the side of our quote-unquote screen. Look at that. You know, a lot of being a game developer is working with illusions like this. It's, you know, looks a whole lot better now than it did before, just after the addition of a couple big black squares. So let's close that. We have, okay, it is 10 p.m. Apologies, but if you'll stay with me for just 10 to 15 more minutes, we will make this a real game, because all we have left to do now is add a little bit of collision and make the game end when if we hit one of the pipes, and then we just have to add a little bit of variation to the vertical position of the pipes when they spawn, so that it's not all just, you know, go on a straight line. So let's get right to that. Go back to the script editor. The first thing we'll do is add that variation to the vertical position of the obstacle spawns. We might as well make those a couple export variables. So let's add a couple more variables here in Game Manager. At export variable, let's see, min obstacle spawn y. That's going to be a float, and let's just give that a ballpark value of like 200, and then at export var max obstacle spawn y, another float. We're going to make that minus 200. And this is just going to be the range within which the position of an obstacle can vary when we spawn it. So we're going to scroll down now to our, or I'll leave that up on the screen for a couple more seconds so we can make sure that everybody gets it. And now we are going to scroll down to the obstacle generation method that we created. And we're going to use a fun little function here. Python also has a similar function. We're going to use randf_range to, add a little randomness to our y value here on our obstacle, and we're going to use as the minimum and the maximum of our random range, we're going to add our min obstacle spawn y and our max obstacle spawn y. Now right away that should make a pretty substantial difference in the look of our game. So once you've got that written out, it's in the y component of our obstacle's new position vector, just give the old game a test, and we can see if that value of 200 and minus 200 was good for like a good level of variation. Uh-oh. Oh wait, no, I'm not moving right. My bad. Okay. Look at that. Starting to look pretty Flappy Birdie, huh? Now, of course, the gap between them is pretty small. We're going to have to make that a bit bigger. But once we do that, we'll have something gamey on our hands. So let's go back to our 2D scene. Zoom back out. Go back to our game manager. Go back to our obstacle gap. And let's bring that back to like 500 or so. Now let's save our game. All right, so the very final last thing that we have to do is add some collision. Now, thankfully, within Godot, this is also pretty easy to do. Let's see. So, our player, as an area 2D, Godot's description of an area 2D was that, quote-unquote, detects collisions. Well, how does it detect collisions? I'll tell you. If we click our player, which is an area 2D, and then go over to the inspector here, you'll notice that inspector is not the only tab on the right here. There's actually another tab called node. And if we click that one, we'll see some interesting things here under this other tab called signals. So each of the this basically represents the inheritance hierarchy of the Area 2D class. It starts as a node, which is inherited by canvas item, which is inherited by collision object 2D, which is finally inherited by Area 2D. Each of these expressions here represent a signal that the object automatically puts out when a certain event happens. So here in Area 2D, we have area entered, which is called whenever another area enters this area. Area exited, self-explanatory. Area shape entered, body shape entered, which are all kind of, well, similar, but not exactly the same, but for our purposes, same diff. So the one we want is area entered, because that gets called when we enter another area, hence it will get called when we hit an obstacle. So we're going to double-click that area entered signal, and this little box will pop up. It says, from signal, connect to script. So we want to connect to a script. And what's actually going to happen is it's going to insert a new function into our script, which is going to automatically get called whenever area entered occurs. So it basically hooks up this signal to a function in the script that we choose right here. So we want it to trip off a function in the player script whenever we collide with another area. So we're going to click our player here, then we're going to look down here. We can leave the receiver method as on area entered. You could also like pick a method that you already have, but for our purposes we can just leave it like this. We can click connect, and then it'll automatically generate that function into our script. So if we click connect, it brings us right to our player controller script, and then if we scroll down, there's that new function. So it might not look any different than a regular function, but it is in fact imbued with a signal. So whenever our player runs into another area object, the code that's in here will get called. Now there is a little bit of extra logic we could do. For example, if we want to add power-ups in the future or something, we could check the area that we've collided with to see if it's an obstacle or if it's a power-up. And we can do that by using groups. So if we click an object here in our scene view, go to the node tab, and then go to the group tab, you can kind kind of add different groups here. You can add and subtract them. Like if we wanted to add like an obstacle group, it's kind of like a tag. And then there's a method that's built in that you can use to check if a given object falls under a certain tag. But the only other collidable objects in our game right now are going to be the obstacles. So we're just going to keep it simple and leave that out for now. For our purposes, whenever we collide with anything, it's going to be an obstacle. And when we collide with an obstacle, we're going to die. So how does that happen? So on area entered, the collision has happened. Honestly, all we have to do right now, if we don't want to go further with anything, we can just, we already have a reference to our game manager here, right? So we can actually just say, remember what we used to, invoke a game over earlier was we set the game started variable to false, and that freezes the player's movement. So let's do game_manager. Remember that game manager variable we defined earlier, .game_started equals false. And that should be all we need to, it won't be very pretty, but we will have a functional game on our hands. We just need to, well actually, you know what, why don't we, in the place of a big game over screen popping up, let's print a little statement that says game over, ! And now, if we were to start our game, all right, so we're going to hit space to start and make sure you're moving to the right with the right arrow key. It doesn't, we should, last thing we should do is go back and make it so you're always moving right, because this is a little silly. So our jump force right now isn't really calibrated to allow us to pass through here very well, so let's just go ahead and die on the, okay, well, I fell off the screen. But let me just restart that so I can demonstrate the collisions. We're moving to the right, we're jumping up and down, and if we hit an obstacle, boom, game over. You can see in our output, the game is over. So I know it's 10 after 10, but if you'll stay with me just 5 more minutes, we're going to do a couple more things to make this game measurably more playable and even a little fun. So let's just go ahead back to the player script. So let's see. Oh, we're already in the player controller script. We're going to go back to our process function, and we're just going to kind of get rid of the left button here. So we're not going to be able to move left anymore. And actually, we don't want to move right only when we're pressing the right key, right? We want to move right all the time. So let's just get rid of that if statement entirely and de-indent that x movement equals x move speed line. And just like that, we're going to be moving to the right forever. So that's one issue solved. And the last thing is we want to mess around with our jump velocity and gravity to make it, feel a little bit more, a little bit better. So make it feel like the odds aren't quite so stacked against us. So we can do that by going back to the scene view, and it's times like these when the export tag comes in handy, because we go to our player, we go from the node tab on the right back to the inspector tab. And up on the top of our player script, we have our x move speed, our jump force, and our gravity force. So I'm feeling like our jump force can be reduced pretty consistently. Let's change that to, let's say, minus 450 is what I'm feeling. And our gravity, let's leave our gravity where it is. Now let's just do a couple rounds of, playing the game, seeing how it feels, to see if this feels a little more, oh, that's good. That's nice. Feels a lot more Flappy Birdie. Oh, okay, we're dead. Well, give me one more second. I feel like we can make this a little nicer. Gravity, I think, is also a little bit too strong. It's pulling us down a little bit too strongly. Why don't we keep with the theme of, actually, let's just make it a little bit. Okay, well, here's the thing. If we lower the force of gravity, then the jump is going to become higher because gravity's not pulling it down as much. So we also have to change jump force if we want to keep our jump the same height, because that felt like a good jump height. So let's make our gravity 450 and change our jump height to like minus 250, or our jump force. Now, if we give it a shot, it should be roughly, okay, well the jump height's still pretty high, but it's manageable. And okay, well that counted as a game over because our guy's hitbox is huge, but that felt a bit better. We can try to, the point is you can keep messing around with this yourself to try and find the perfect combination of lateral speed, jump height, and gravity to make this feel like a real great Flappy Bird-like. But we have here a game, and it is playable, and that's something to be proud of. Thank you everybody for coming. So let's get a show of hands. How many of you guys managed to follow all the way through and have something like playable like this? Solid, very solid. We're gonna finish up soon, and then if any of you guys like want help finishing it up, I'll come by and lend you guys a hand, no problem. But yeah, thank you for sticking by us in this emotional roller coaster of a workshop. I hope you feel that you've gotten a bit of experience with Godot, with some of its basic functions, and I hope that this has given you some ideas, of improvements you could make, of ways you could maybe make your own game, So, thanks again all you guys for coming. Thanks again for Hack the Hill and CSSA for helping us host this thing. I almost forgot. All right, workshop over, but we are going to announce the theme of our upcoming uOttawa Game Dev Club Halloween Game Jam, which will be starting tomorrow and going until October 31st, after which we'll be having a huge game night to show off all the games. But yeah. Sorry, starting on Sunday, so don't, this is kind of a sneak peek, so don't get too into it just yet. As I said, the jam will be running from October 1st to October 31st, and the theme of the jam will be cryptid. Blah. So, I don't know. If you want to make a game about Sasquatches, about, like vampires, if you want to make up your own cryptid, it's all on the table. It doesn't even really have to be spooky. You can make like a marsh monster dating simulator or something, but as long as there's cryptids in it, it's valid. So, thanks again you guys for coming. I will now go around and help those of you who still are running into errors, because I'm sure there are plenty of you who have. Thanks again for coming. On Hack the Hill's, it's been streamed on YouTube, and it will be available on Hack the Hill's YouTube. I'll record a better one. The code for the original game, which was going to be, much more complex than this, is on GitHub, and we have sent out the link on our Discord announcement. So if you want to get a glimpse into the inner workings of the original game, there are some additional features of Godot that were explored in that one that were not quite explored in here. All the code in there is, commented, so if you feel like that, checking it out, please feel free. And I very well may at this point record just like a standalone tutorial for the original game, because it was pretty cool and quite a bit more substantial than Flappy Bird. So, all right, that is all. Thank you.